Okay, so in today's video we're going to have a look at graph transformations. Now we're going to have a look at this question, so grab a piece of paper, grab a pen, and we're going to have a look at the ways that we can approach these questions. Now what I'm not going to do in this video is I'm not going to spend a lot of time talking about the why it happens the way it does when we're looking at graph transformations here. We could probably spend about 2 to 3 hours actually looking at that because it is quite complicated in the way that we have to draw it. So what I am going to have actually go about is just showing you how to answer questions like this in a nice, clear and easy way, hopefully for you. Okay, so this question says the diagram shows part of a curve with equation y equals f of x. Okay, so it's the function of x. We don't know what the equation of the curve is. That f of x, the function of x just means with a particular equation. Okay, so it says the maximum point of the curve has the coordinates 2, 3. Write down the coordinates of the maximum point with the equation, and we're going to discuss some of these different types of equations. Okay, but this is typically how a question would be phrased. Now we can see on the diagram there the maximum point being that this point here. If I draw on that, there we go, this point here does actually have the maximum point 2, 3. Okay, so I'm just going to get rid of that, but what we're going to have a look at is how we could approach different questions here. So when we change the function, we can do things either to the x coordinate or the y coordinate or a combination of the two. And the way that we do that is by placing the numbers within this f of x, y equals f of x. And we can either place numbers or symbols next to the x or outside of the bracket there, outside of the x. Okay, and there's a simple little set of instructions that you can remember for how it actually moves the coordinates. So either we're going to put things next to the x, and when I say things next to the x, I mean we can do the function of, and we could do x, and we could put a +2 in there next to the x. Okay, so that's one option of something we could have a look at. Hopefully you've obviously seen these before. So either we're going to put things next to the x, or we're going to put things outside of the x, which is going to affect the y coordinate. So if it is next to the x or inside the bracket, okay, it's going to do the opposite of what we'd expect. Okay, so it's going to do the opposite, and we'll discuss that in a sec. There we go, it's going to do the opposite. And if it's outside of the brackets and it affects the y, it does what we'd expect. Okay, what you expect. Okay, so if it affects the x, it's inside the bracket. So we'll put inside bracket. And if it affects the y, it's when it's outside the bracket. There we go. So if we can remember this little set of instructions here, it's going to help us to answer pretty much all the questions on this. So if it's next to the x inside the bracket, it does the opposite. And if it's outside the bracket, it affects the y and does what you expect. So something like this up here, which I've drawn already, f of x plus 2. Plus 2 there is inside the bracket. Okay, so it affects the x coordinate, and it does the opposite of what we'd expect. So rather than adding 2 to the x coordinate, it subtracts 2 from the x coordinate. So this one in particular, and again we're going to have a look at all these different types of questions, but this coordinate here, the x coordinate there is 2. So if I was to do this function of x plus 2 here, we would subtract 2 from the x coordinate, so 2 take away 2 would give us 0, and the y coordinate wouldn't change, it would be a 3. Okay, now the only scenario where this doesn't actually follow the opposite and what you'd expect scenario is when it's a minus that we put in there, which we're going to have a look at in a sec. The minus just follows and it does what you'd expect no matter whether it's inside or outside the bracket, but we're going to have a look at some of these now. Okay, but a simple little set of instructions there to remember and to write down. If it affects the x coordinate, it's inside the bracket and it does the opposite of what you'd expect. And when we're looking at the y coordinate, that's outside the bracket and it does what you'd expect. Okay, so inside the bracket, opposite x, outside the bracket, what you'd expect, and affects y. Okay, so let's have a look at some of these. Okay, so same question that we were just looking at, but we've got some questions here that we're going to have a look at actually answering here. So it says the diagram shows the part of the curve with the equation y equals f of x, and here it is in the diagram. The maximum point of the curve is 2, 3, as we've already seen. Write down the coordinates of the maximum point with these different equations, and I've got quite a lot here, all the different scenarios we could actually have a look at. So for part A there, okay, it says f of x minus 2. So that's inside the bracket, so it affects the x coordinate, and it does the opposite of what we'd expect. So it doesn't subtract 2, it adds 2. Okay, so it just does the opposite. So the x coordinate being 2 there, we would add 2 to the x coordinate and that would make it 4. And the y coordinate's not going to change, so that would stay as 3. Okay, so that's the opposite of what we'd expect, and we add 2 to the x coordinate. Looking at the next one, let's try to change to a different colour here. Right, so f of x minus 1. Now that -1 is outside of the bracket, so it's outside the bracket, it affects y, and it does exactly what we'd expect. So -1, we would expect that to subtract 1 from the y coordinate, which it does. It just changes the y-intercept actually. If you're familiar with your equations of lines and your coordinates, coordinate geometry, you should hopefully know that number at the end is the y-intercept there. So it's taken away 1 from the y-intercept, essentially just moving the graph down 1, but we'll have a look at that again a little bit later. But minusing 1 from the y-coordinate currently is 3. So if we take 1 away from that, the x-coordinate doesn't change, so 2. But the y-coordinate's also going to drop down there to 2. It's going to subtract 1 from that. Okay, so that's how we could have different scenarios there with just adding and subtracting numbers and how that affects the x and y coordinate. Now we're going to have a look at question C, part C there. So y equals f of 2x. So 2 times x. Normally when you're timesing by 2, you'd expect that to double something, but as it's inside the bracket affecting x, it does the opposite. So rather than multiplying by 2, it divides it by 2 or halves it there. So if we look at the x-coordinate is currently 2. So half of that, halving it because it's inside the bracket and changing the x-coordinate, but does the opposite. So half of 2 is 1, and the y-coordinate remains unchanged, and that remains as 3. There we go. So that's that one. Let's have a look at the other scenario where it's outside the bracket. So 3 lots of f of x for part D here. Let's have a look at what this does. So it's outside the bracket, it affects y, we're multiplying it by 3. So it does what we'd expect, it makes it 3 times bigger, but it affects the y coordinate this time because it's outside the x bracket. So 3 lots of that y coordinate, the y coordinate's currently 3, so the x coordinate is unchanged and the y coordinate gets multiplied by 3 and becomes 9. Right, there we go. So that is our scenarios where we are multiplying by a number. So in terms of the x there, inside the bracket 2x does the opposite, so divided by 2, but outside the bracket it multiplied the y coordinate by 3. Okay, and onto these negative ones here, which don't really follow the same trend, but partly it does. So we'll have a look at this one here. So when we've got minus x in there, now it doesn't do the opposite of what we'd expect, because the opposite of minus x would just be nothing. Okay, we wouldn't actually change anything at all, it'd just be positive x, it'd be the same equation. Okay, but we follow the rest of the rules for this one. It's just that it goes a little bit out the window when we look at our minuses here. So when we've got a minus in there, all that does is it swaps the symbol of the x coordinate. It's still affecting x, it's inside the bracket, it just doesn't do the opposite this time. Okay, so it just changes the 2 as the x coordinate to minus 2. So the x-coordinate's going to change, it becomes minus 2, and the y-coordinate remains unchanged, stays as 3. Okay, so this when there's a negative in there, that's the only scenario where it doesn't actually do the opposite or anything like that. We just have to worry about, is it next to the x or is it changing the y, and it just flips the sign. So the last one here, we've got y equals minus f of x, and again the minus there is outside the bracket, so it changes the y-coordinate, and again it just swaps the sign, so instead of being positive 3 there as the y-coordinate, it's going to be negative 3. So we have positive 2 still and negative 3. Okay, so again, just following all those little rules. Is it next to x or is it next to the y or outside of the x bracket? And that tells us which coordinate it affects. When it comes to adding, subtracting, multiplying, okay, we can think about the opposite or whether it does what we'd expect. The only scenario where it doesn't is where we've got this little minus symbol in there, and that just changes the positive or negative symbol of the corresponding coordinate, whether it's x or y, whether it's inside the bracket or outside the bracket. Okay, let's have a look at one more. Okay, so on to a different question. We've got the diagram shows part of the curve of the equation y equals f of x, and it says the minimum point of the curve has the coordinates 3 minus 4. We can see that down here on the diagram. It then says write down the coordinates of the minimum point with the equation, and again we've got 3 equations here. Now you probably notice there's a lot more going on in these. So we've got f of x minus 2 and then plus 3 at the end. Now we've got 2 transformations essentially, or 2 things happening here. We'll look at why it's a transformation in a sec, for how it moves. Obviously a transformation just being how a graph moves around. So we're going to have a look at what this does. So in here we've got f of x minus 2, so we've got something happening here and we've got something happening here as well. Now one is inside the bracket, one's outside, so this means the x and the y coordinate is going to change, but again we're just going to follow our little simple rules and do it step by step. So if I first start with this minus 2 in the bracket, that affects the x-coordinate. So the x-coordinate's currently 3, and that does the opposite of what we'd expect. So we're not going to take away 2 from the x-coordinate, we're going to add 2. So adding 2 to that x-coordinate, 3 plus 2 gives us 5 for the first coordinate there, and that's that first bit dealt with. We've then got the plus 3 at the end, and when it's outside the bracket it affects the y coordinate, and it does what we'd expect, so it adds 3 to the y coordinate. So negative 4 add 3 gives us negative 1, and there is our coordinate there with those two transformations, okay? So it is, if you think about what that actually does, it moves it right by 2 spaces, the 3 moves across to 5, and then it goes up 3 places as well. So if you think about what this is going to look like, it's going to move right and up, so it's going to be over here somewhere, that new minimum point, okay? But let's have a look what this does. If we could draw a little sketch in, okay, it would look something like this. There you go, that's what that transformation would do. Let's have a look at another one. So we've got the part B, it says f of minus x and then minus 1 at the end. So the minus x part, that's going to swap the symbol on the x coordinate. So the current 3 is going to become negative 3, changing it from positive to negative. Again, not worrying about doing the opposite there when it's just a minus symbol. And then we've got the minus 1 at the end, which affects the y coordinate, and it does what we'd expect. It drops it by 1, so it goes from minus 4, which it currently is, down to minus 5. And again, I'm doing all these questions separate from one another as if they were separate questions, so we're not going from one graph to the other, we're starting from that original graph. So I was again looking at the 3 minus 4, not the new minimum point that we created on the question on part A there. So minus 3 minus 5 being our second one. And again, we'll have a look at what that actually looks like with the minus symbol there. It's a little bit more complicated for me to sketch it out on this one for you, but we will have a look at some sketching in a sec, so bear with me on that one. And on to the last one here, we've got y equals minus f of 2x. Okay, so this one just here. So the minus on the outside affects the y coordinate, and again it flips the symbol. So if we're doing that bit first, let's have a think. Leave a little empty gap for that one there. So the y coordinate is going to change symbols, so it's going to go from minus 4 to positive 4. Then looking at the 2x, that's inside the bracket, so it does the opposite of what we'd expect. So instead of timesing the x coordinate by 2, it's going to divide it by 2. And the current x coordinate is 3, so dividing that by 2 is not going to give us a whole number there, it's going to give us 1.5. There we go. And we can have decimal coordinates as well. That's absolutely fine. It's just halfway between 1 and 2, isn't it? So 1.5 being our x coordinate. Okay, so that is how our transformations are going to work. So just remember that little table. If it's inside the bracket, it affects x, and it does the opposite of what you'd expect. And if it's outside the bracket, it affects the y coordinate, and it does logically what you'd expect there. The only scenario where it doesn't is obviously with the minus symbol. And again, that's only when it's inside the bracket. It just does what you'd expect there. It just doesn't do the opposite. Okay, so here's a couple for you to have a go at. Okay, so quite a few questions on this. You've got 2 questions, one on the left, one on the right, and 4 parts on each question. 3 parts that are doing single transformations or single movements, and then you've got the part D on both where it's doing 2 transformations for those 2. So you've got the minimum points on each one, you've got the maximum point on the first one, you've got a minimum point on the first one. They're the coordinates that you need to change. So have a read through, pause the video there, and we'll go over the answers in a sec. Okay, so looking at the first one. So part A for this one divides the x coordinate by 2. So we would have 2, 5, the opposite of what you'd expect there, changing the x coordinate. On to the next one, changing the x coordinate again, but it does the opposite of what you'd expect, so adding 3. 4 add 3 is 7, and the y coordinate again is unchanged, so 7, 5. On to this third one, negative on the outside, so it changes the y, so we're not changing the x, so that stays as a 4, and y becomes negative, so it becomes minus 5. And now to the last one, we've got 2 transformations to do. We've got to subtract 2 from the x coordinate, the opposite there inside the bracket, so 2, and we've got to take away 1 from the y coordinate, 4. Right, and on to the second one here. So we've got 5 minus 2 as our coordinate, so 3 on the outside of the bracket for part A multiplies the y coordinate by 3, so it becomes 5 minus 6. Part B, inside the bracket, subtracting 4 from x, so we have 1 minus 2. On to part C, minus x, so that's going to change the x coordinate symbol, so minus 5, minus 2. And on to the last one here, 2 transformations. We've got dividing the x coordinate by 2 and adding 3 to the y coordinate. So the x coordinate is 5, divide that by 2 is 2.5, and then adding 3 to the y coordinate sends it from minus 2 up to positive 1, so it's 2.51. Right, let's have a look at sketching some of these. Okay, so it says the diagram shows part of a curve with equation y equals f of x. Draw a sketch of the graph with these 2 equations. I'm going to do 2 on 1 graph just to save a bit of time here. So part A says to draw y equals f of x minus 4. Now we know that x minus 4 here is going to plus 4 to all the y, or to the x coordinates. So add 4 to x. Okay, now all we've got to do is make sure that we find any whole number coordinates on this graph, and they're the key ones. So I can see quite a few, and I'm going to highlight them here. So we've got one here, we've got one here, and we've got a few down the bottom here that go through actual whole number coordinates. So they are the coordinates that I need to make sure I move perfectly when I'm drawing my little sketch. The rest, we can just do it as accurately as we can. So if we're going to add 4 to the x coordinate, well, let's look at this one here to start with. That coordinate there currently is 0, 4. So when I add 4 to the x coordinate, that is going to become 4, 4, okay, adding 4 to the 0. So 4, 4 is the coordinate here. And you can see there, that's moved it right 4 spaces, and that's what that transformation there actually does. Okay, so when we actually add 4 to the x coordinates, they're all going to move right 4, and therefore it's going to be translated, okay, to the right. Okay, so we're translating it 4 to the right. Now looking at the other one, this one here, if I move that 4, that's going to land on top of that 0, 4 coordinate, so I can't draw over the top of that, but that's where that's going to move. The one down the bottom here, this -2, that if we move that right 4, that's going to go to here, and then moving the others right 4 is going to place them there and there. There we go. And that is how they would move. Now if I just get rid of some of these bits here, because we're going to do another one in a sec. Let's get rid of all of them, and let's just sketch that in. And you've got to just do this nice and neat, okay, as best you can, drawing a nice smooth curve, making it look as best as you can like the one on the graph there. There we go. So not perfect with my lines there, but just moving it right 4 and showing that it goes through those whole number coordinates. And let's have a look at part B here. We've got y equals f of minus x. Now minus x, we know, changes the symbol on the x coordinates. So again, if we pick a coordinate, and let's pick this one to start with. Okay, so this one here, and let's label this over here, that coordinate there is -2, 0. Okay, so if we swap the symbol on the x coordinate there, that's going to become +2, 0. Okay, so +2, 0. Again, let's get rid of this first graph. +2, 0 is here. There we go. So let's have a look at another one. Let's pick this coordinate here. There we go. So that coordinate there is -1, 0. And if we change the symbol in front of the x coordinate, that becomes +1, 0. So +1, 0 is there. And let's have a look at one more down here on the bottom. We might be able to figure out where the rest are going to go afterwards. This one here is -3, 0. And again, swapping the x coordinate there, that becomes +3, 0. Which is just here. So hopefully you can see it. Actually, this curve is going to end up in exactly the same place as the last one. But what's actually happening here, let's have a look, let's just get rid of all this so we can see it a bit better, is something slightly different to the last one, because that last one was a transformation. It was actually moving right 4. Whereas if you have a look at, and I'll try and do them in a different colour here, this coordinate here, the purple one, moved to this coordinate here. So actually it's not being moved in the same way, because as well this coordinate here is moved to this coordinate here. What this is actually doing is reflecting the shape in the y-axis. Okay, and you might actually be able to see that this coordinate here as well would move to, just make sure I do this carefully now that I'm not writing down the coordinates, it would move to there, and the coordinate which is here on the axes is not going to move anywhere, it's going to stay where it is. So actually what's happened is the curve has been reflected, but actually all you've got to do is reflect those, or change the symbol in front of those x coordinates, and again just sketching it in nice and neat. So it's quite unique there because, oh, there we go, not very good there. Make sure you do go through the coordinate points. But although there were two different transformations there, two different changes in the function, the graph did end up in the same place, but there were different transformations. One's a reflection and one was a translation. Okay, but as it turned out, they ended up in the same place for that one. But let's have a look at another one. Okay, so we have a slightly different curve here. It says the diagram shows part of a curve with equation y equals f of x. Draw a sketch of the graph with equation, and then we have two different equations. So for the first one here, we have f of x add 2. So that +2 at the end there means we are moving in the y direction, and specifically we are going to add 2 to the y coordinates. Now we'll see what happens obviously when we do that, but if we add 2 to the y coordinates, we just need to find some whole number coordinates to do that to. So if we look at our curve, we've got one here, we've got another one down here on the origin, we've got another one just there, And we have another one. Well, we've actually got another 2, but we've got another one that's down here that's quite nice and easy for us to do as well. But we've got this one just here. So there are 5 coordinates there that are quite nice and easy for us to add 2 to. And if we do that, that would be up 2 for here. We're going to go up 2 for there, up 2 for here, and for the other 2, just moving those up 2. Now we can obviously draw that in. You can already see what the curve looks like. So obviously you just want to make sure that's nice and neat, up, down, and drawing your curve as best as you can to try and replicate the one that you can see. So there we go, that is +2 to the y coordinates. Now for part B, we've got a slightly different equation again. We've got minus f of x. Now that minus is outside of the bracket, so again it is affecting the y coordinates, and it's just going to change the sign from positive to negative or from negative to positive. So for this second one, I'm just going to get rid of the first one that we drew. So we'll get rid of that and we'll have a look at this second one. So for this, if we look at the y coordinates, and any that are positive will make them negative. So that one on the very right there that has a y coordinate of 3, that's going to have a y coordinate of -3. So that's going to go down to here. Now to the left of that, that has a y coordinate of 0. So that will stay as 0. So I'll leave that just there. The next one has a y coordinate of 2, so that will go down to -2. This one again is 0, so that will stay as 0. And then this final one here has a y coordinate of -2, so that's going to have a y coordinate of +2. So actually what this does, and you can see when you draw it, this actually does a reflection in the x-axis. Okay, and that's what happens when all the y coordinates change signs. If instead the minus was inside the bracket, so it was equals or y equals f of, and in brackets minus x, that would actually change the signs in front of all the x coordinates, and that would be a reflection in the y-axis. And again, once you draw these and change the coordinates, you can see why that happens. But there we go, that is 2 little parts of a question that we could have a look at as well. Okay, so here are 2 for you to have a go at. Okay, so you've got 2 questions here. Obviously, don't expect you to actually draw these, but have a think about where they would move and how they would look. You can always draw a little sketch of them if you want. It's not going to be too difficult just to do a little sketch. You won't be able to do the coordinates perfectly unless you've got some graph paper. But you could actually have a go at just thinking about what they're going to look like on the screen. Okay, so for each question there are 2 parts, part A and B. So have a go, think about where they'd go, pause the video there, and we'll give the answer in a sec. Okay, so this first one. So if we have a look at this one to start with, we've got a -4 on the outside, which changes all the y coordinates. So essentially it's going to move down 4. So if we start with this bottom minimum point here, that's going to go down 4, down to -4. And then all the rest of these whole number coordinates here, which I'll highlight, are all going to go down 4. And if I just move them all down 4, that's going to be here and here. And then those upper ones are going to go down 4, down to here and here. And again, I just need to try and draw a little sketch of the graph that I can see, and there we go, as best as you can. Right, on to the next one. We've got minus f of x, so that's outside the bracket again, so it's going to affect the y coordinates, and it's going to flip the signs on them. So these top ones up here, which have y coordinates of 4, are going to go down to y coordinates of -4, -4. There we go. The one on the axis here isn't going to change because the y coordinate's 0, but these 2 are going to change here. These +1 y coordinates are going to go down to -1. There we go. And as you can see, that's done our reflection there in the x-axis. Okay, so just making sure you go through all those whole number coordinates. Now, you normally wouldn't have 2 on top of each other like that, but so we've got a few more on the screen here. We've got 2 on each one. So let's have a look at the next one. We've got y equals f of x -3. So that's going to affect the x coordinates, and it's going to go right 3 or add 3 to all of them. So we've got a few here to move. We've got this one. We've got this one. Let's have a look. This one here, and this one here. And they are all going to go right 3. So starting from the right, let's move that right 3, that one right 3, that one right 3. Let's have a look. The next one there is quite close. Right 3. And where's the last one? Right 3 is there. There we go. And then obviously just drawing that up as best as you can with a nice smooth curve, going through all those coordinates. There we go, and there's your little graph transformation there. And on to the last one, we've got minus x, so changing the x coordinates there, flipping the signs on the x coordinates. So this one here has an x coordinate of 3, and that's going to go to -3, which is over here. We've got this one here, which is on 0, so that's not going to change. We've got -2 here, which is going to go to +2, which is going to be there. Gets a bit messy on top of each other here. So we've got -4 that's going to go to +4, And we've got this one here, which is at -5, and that's going to go to +5. Right. That is going to be quite difficult for me to draw on top of there. Let's think about what this is going to look like. Okay, so as best as I can. Oh, start that one again. So that's going to go up through here, down and up, and actually it extends a little bit, so we could extend it a little bit there. There we go. So it does a reflection there in the y-axis, okay, just reflecting it around as best as you can, but obviously you can only do your best there with your sketches, but that hopefully gives you a general idea of what these actual graph transformations actually do to the graph. Now I've got one more for you to have a look at before we finish. Okay, so last question. We've got the curve with the equation f of x is transformed on the graph. And here's our equation f of x, so it's this graph on the left here. Write the equation of the transformed curve. Now there are so many different ones of these, but it just follows all the rules that we've just looked at before. So this actual graph here, if you have a look, f of x, the points have moved. Okay, so this point here has moved to this point here, and that has gone over to the right. Okay, having a look at this point here, it's moved to here, and again it's gone over to the right. And the same for the last one. These 2 points here have moved over to the right. Now what we can actually do is use the number down the bottom for this one. Okay, we can see down here it goes from 0 to 4. So it has gone right 4, or 4 has been added to the x coordinate there. Okay, let's just actually write that a bit higher. There we go. So that has added 4 to the x coordinate. Now if we are changing the x coordinate, that means it has to go inside the bracket, doesn't it? So we would have y equals f of, and in the bracket, x, and to move right 4 or +4, we have to write the opposite, so it would be -4. There we go. And that would be the equation of this curve on the right. And there's obviously so many different ones that you could do here, but all you need to make sure you do on a question like this is find the coordinates, see what's happened to them, and obviously just relate that and correspond it back to our little table there. Has the x coordinate changed, in which case it's in the bracket? Have the y coordinates changed, in which case they're going to be outside the bracket? Okay. The only one you need to be careful of is when it's a reflection, just making sure that you are careful there, because it's a little bit of an opposite, isn't it? When it's inside the bracket, a minus inside the bracket does a reflection in the y-axis, and a minus outside the bracket does a reflection in the x-axis, but it changes the corresponding coordinates. So inside the bracket with a minus changes the x-coordinates, which does a reflection in y, and outside the bracket changes the y-coordinates, but ends up doing a reflection in x. But there is just one little question there to be thinking about and how you would apply this. Okay, if you did have to write the equation of the transformed curve or graph or whatever it is that you have to do. But there we go, a bit of an overview on transformation of graphs. Hopefully you found that useful. If it was helpful, please like, please comment, please subscribe, and I'll see you for the next one.